This is AP Calculus AB, looking at the 2010 released question, number 5 from Form B. Consider the differential equation dy over dx equals x plus 1 divided by y. On the axis provided, sketch a slope field for the given differential equation at the 12 points indicated. That's from -1 to 1. I think they would have that being inclusive. Anyhow, sketch the solution curve that passes. Oh, okay. So this is the second part. And from -1 to 1, not inclusive, sketch the solution curve that passes through 0, -1. All right, let's do the first part, which is sketch the slope field. So we have dy over dx is x plus 1 over y. So I'm going to first take and figure out any time that y is 0, doesn't matter what the top is, this is going to be undefined. So y is 0. If it's undefined, it means it's going to be vertical. So we got 3 of those done. Let's try to figure out when is the slope going to be 0. The slope's going to be 0 whenever the numerator is 0 and the denominator is not 0. So this will be 0 whenever x is -1, because -1 plus 1 is 0. This is -1. This x is -1, x is -1, x is -1. At these 4 locations, x is -1 and the slope is 0. So we got those covered pretty quickly. Well, what happens when, I don't know if we can mass do these other ones, so I'm just going to make a table. So we got the ordered pair. Let's say this is 0. Let's do this. If the x value is 0, let's say the y value is 2. That's going to be 1 over 2. That's a half. So maybe look a little something like this. How about it 0, 1? That's going to be 1 over 1, which is 1. Maybe it looks a little like that. Let's go 0, -1. It's going to be a slope of -1. And then at 0, -2, it's going to be 1 over -2, which is -1/2. Starting to cram together here. Now let's do it whenever x is 1. So we got 1, 2, 1, 1, 1, -1, and 1, -2. So if x is 1, the numerator is going to be 2 each time. So it's 2, 2, which is 1. We're going to have 2 over 1, which is 2. 2 over -1 is -2. And 2 over -2 is -1. So here it's at -1. Here is -2. Here is +2. Here is +1. So we get 1 point. I believe how this works for this one, as far as scoring goes, you get 1 point if you correctly label all the places where it's 0 and undefined. Then you get another point for correctly labeling all the places where it's positive or negative. But there's a second part of this question, which is, between -1 and 1, non-inclusive, sketch the solution curve that passes through the point 0, -1. Well, the solution curve that passes through 0, -1, I believe, is just simply going to be something like this. It's too thick, sorry. Maybe something like that. I just look real quick. I'm sorry to do this to you. I'm going to look up on the key just to make sure that that's all we got to do for that. I'm sorry. This is 2010. I'm using my other computer. Question 5, scoring guidelines. Not entirely. Yeah, that's pretty much all it is. All right. Part B. While the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane as long as y isn't 0. Describe all points in the xy plane as long as y isn't 0 for which dy over dx is -1. All right, so have we've established already dy over dx is x plus 1 over y. If we're saying that equals -1, and we multiply both sides by y, and we get y by itself, we're going to get this, y equals -x minus 1. By doing that, what we are saying is, if the slope's -1, then the equation y equals -x minus 1 is an equation that's going to accept all the different possible values to give you a slope of -1, as long as y isn't 0. So let me write that down. dy over dx equals -1 for all points in the plane where y equals -x minus 1 and y doesn't equal 0. You get 1 point for saying that. This work that I did over here was just for me to get to the point where saying y equals x, -x minus 1. Part C, find a particular solution to the given differential with the initial condition 0, 3. So once again, we take the differential and we separate the variables. Separating the variables, we get y dy equals the sum of x and 1 dx. If you integrate both sides, the left side with respect to y, the right side with respect to x, make sure you add in your arbitrary constant. We want to evaluate this at the ordered pair 0, 3. So we're going to put 3 in for y, 0 in for x. The left, we're going to get 9 halves. The right, we're going to get 0 plus c, which is just c. So we have 1/2 y squared equals 1/2 x squared plus x plus 9 halves. Now to find the particular solution, we need to get y by itself. If we multiply every term by 2, we get y squared is x squared plus 2x plus a 9er. That's trucker talk for 9. If you square root both sides, you get y by itself. We get 2 different answers. But we can't have 2 answers unless both answers work. We need an answer that contains 0, 3. So which equation, there's 2 there, contains 0, 3? Well, the one that contains 0, 3 is the positive one, because 3 is positive. That is our particular solution. As far as points go, you get 1 point for getting the particular solution correctly. You get 1 point for finding C correctly. Pardon me. You get 1 point for evaluating at 0, 3. You get 1 point for integrating both sides correctly, not each side correctly. And most of the time in the other ones, we got 1 point for each side. And then a point for separating your variables correctly. So 1, 2, 3, 4, 5, 6, 7, 8. I'm missing a point someplace. Oh, up here, we got a point for that blue curve segment. All right, that concludes this problem.